And this is just an application of Kirchhoff's, or Kirchhoff's sometimes they call it, it's up to you, rules. So the first rule of Kirchhoff's, as you know, they call it junction law or rule. Okay, so what does junction rule means? Okay, if you have current coming in this direction, for instance, to this junction here, and a junction means a branch or a point that you have many branches, okay, at that junction point. So if we said that this is I1 is going inside and this is I2 is upward, so you can see I1 and I2, when they meet together, they go together. They are not cancelling each other. So this is why they are not vectors. They are scalar. So this is why we can add them together easily. Okay? And then we get I3 here. I3. So actually I3 equals to I1 plus I2. Okay? And we can sum them up all in one side. So we can say I3 minus I1 minus I2 equals 0. So we can say something else here. Okay? So this the summation of all currents here, okay, equals 0. And this is the first rule. So the incoming currents to that junction, specific junction, okay, equals to the leaving currents from the same junction. Okay? And this is the first rule. The second rule is the same thing like that one, but actually it is different with something else. That one we call it the addition all potentials, all electric potentials, which are, because the actually charge is conserved, okay, within the circuit. So therefore, the addition, as we saw from our example, we just saw this example now. Okay, we saw that this the voltage of the main supply is just, okay, transferred to be dissipated or drop voltages across all the resistors. Okay, so it's the same thing here. If we can sum up, okay, all of these voltages, whether it is voltage coming from the battery or the voltages dissipated within the resistors, we can add them together in one side, okay, in that closed loop. So that closed path or a circuit, sorry, or a loop, we can add them together, all of these potentials. So that summation equals to 0 again. Okay. And then inshallah we'll see an example for these loops. So this is the second rule for Kirchhoff's. Okay. So the summation of all voltages, okay, also equals to 0, but this is in a closed loop. Don't forget this. Okay. Okay, so let's get trained. How can we deal with this network that have been given, or the circuit? The question here: find I1, I2, and I3 in this circuit. So what's I1, I2, and I3? Let's change the color of this pen. Okay, let's take this green color here. So let's call this one A, and this is B, this is C, and this is a D. Okay. So now, if we wanted to find, okay, or apply the two rules of Kirchhoff's, first of all, we'll take the first rule. Okay. So what is the correct junction that can bring all of these unknowns, these unknown currents? Okay. In our case, these three unknowns are currents. Okay. So if we can see this junction here at D, okay, D point, this junction, okay, you can see that there is current I is coming in to that junction. Another one is coming, I3, from this side. And then these two, they will meet here, and then they give me I2. Okay, so direct, I can say that I2 equals to, direct I2 equals to I1 plus Yes, right, I3, correct. So this is my first equation actually. Also, I can choose this junction here, up here, okay, at P. Why is that? Because also I have here the same current is coming up, which is I2. Actually, this is the same current here flowing here. And we have here also I1. Okay? So I1 is also the same current which is enters R1 here. And then we have here also I3. This is I3. Okay. That can go through this battery and then comes back to here again. At this junction, you can see I2 again equals to I1 plus I3, which is the same equation here. Okay? Very nice. Okay. After you just finish the first rule of Kirchhoff's, now you go for the second rule. How can you add up all of these potentials, all of these voltages? First of all, you should choose a loop. Okay? So the loop, actually, it is up to you. You can choose it clockwise, okay, anti-clockwise, but it should be closed. Okay. So let's take this loop here for this a small circuit here. Okay. So we'll take this path A, B, C, D, again A. So start from A and come back to A. So this is our first loop here. This is loop number 1. Okay. Now, if you can see, our loop starts from A to B, but we will face directly the supply battery here. You see, this is minus, so this is low potential, as we said, and this is high potential here, high potential. Okay? So we are moving from low to high, and our direction always will be positive. Okay? If it's positive, we are moving. You should ask yourself, are you going with your path from A to B? Yes, I'm going from A to B. Okay, so now your path is going from A to B. What about the battery? When you go from A to B, is battery going from minus to positive? Yes. So we'll take it as a positive sign for the voltage for V1. So V1 here to be positive. Okay. Now you continue. What about BC? BC, we have a current, but we don't have any resistance. Because we don't have any resistance, so that means there is no voltage. Okay, so no need to do anything. What about CD? You can see CD here, CD. You see that the current I3 now trying to enter R1. Sorry, I1. It's not I3. I'm sorry, I1. So it tries to enter R1 here. Okay. So there is a drop in the voltage. So we should consider that one. And now you should concentrate on the minus sign here. So the minus sign, okay, of that voltage, which is again R1 into I1. Okay. Why we took it minus? Because as I told you, this is now we have a dissipation voltage. Now the resistance try to handle the current. Okay, so there's a challenge. And because we are moving with the loop, with the path direction, okay? Because now, let's just conclude something from here. Okay? So let's say that this is a resistor R, okay? And this is the direction of the current, I. Okay? Our loop is also going with the current now. So this is loop going in that direction, okay? And the current is the same thing with the loop. In this case, the voltage here counted, it will be minus I into R. Okay? But if we have something else now, if the current is going in this direction, okay, and this is another R, okay, but our loop direction is here, and you choose the loop to be opposite to the direction of the current. In this case only, and only in this case, you will take here the voltage, the drop of the voltage will be positive I into R. Okay. It will be positive V here. Why is that? Because your loop your path direction is opposite to the original current direction. Okay? Don't forget this. So now we'll finish. Did you finish? No, we only moving from C to D. We are remaining with this last portion of the path, D to A. Now when we move from D to A, okay, we are moving with the current I2. Okay, we are facing this R2, and because we are moving with the loop direction, so it will be another minus sign here, R2, I2. And if we can sum up all of these together, this will be equal to 0. Okay, my dear students, are you following now? Okay, if you make your first, let's say the second actually equation, because that is the first one here, I2 equals to I1 and I2. Okay, then you can just plug in numbers. So we know V1 is 24 minus R1 is just 8, I1 is unknown. Okay, R2 is 6, I2 equals to 0. From here you can just play with it. It's up to you. You can take I1, which is the first unknown, okay, in terms of the second unknown, which is I2, and you can make it mean the opposite. It's up to you. Nothing here is important. So I mean, there's nothing is preferred. It's up to you here. So let's call here. Let's just move I2 to the other side. I2 equals to 24 minus 6, sorry, 8, I1. Okay. And then we can divide by 6 here. So I2, and this will be I2 equals to 4 minus 4 over 3 I1. And we call this one number 2. Let's call it number 2, equation number 2, okay? Okay, so now we have the first equation coming from our first loop. Now we'll continue with another path. Let's change the color here. Take this color, okay? So now we'll take another loop and see how can also we make another equation. So let's take this loop here. Let's call this one E. Let's call this one here E, and this is F. Okay. This is J. And this is D. Okay. So now let's take this loop here, which is D, C, F, E, F, G, D. Okay. So let's take that one. So this is called now loop number 2, and it is D. Okay, we are just starting from D, and then we end with D. So it's D, C, B, E, F, G, again D. Okay. So that is this is our loop actually here. And this is the second loop, and actually it is going from D to C, and it's a closed loop. It should be a closed loop, okay? So DC, this is DC. You see now, it is not CD, it is DC. So you go with your loop, the red one now, this red loop here, you go like that, and then go up like that, okay? So we are going up from D to C. You can see our loop direction is opposing the current direction. Okay? So in this case, and only in this case, the voltage now become positive. Okay? So I1 into R1, it will be a positive sign. Okay? So here it will be R1, I1. Okay? And it has a positive sign here. Okay? Then DC is finished. BE, nothing here, nothing in BE, nothing in EF, but in FG we have this battery. Now you see this is the direction of the loop, okay, and also this is the direction of the current. Don't forget that. Okay, I3. So they are in the same direction, and because they are in the same direction, we are taking the voltage negative here, as you see here. Yeah. So, but this is not across a resistor. Don't forget, this is across what we call it battery, and because we are moving from high potential to low potential, okay, low potential. In this case, the arrow is not pointing to the positive sign, it is negative sign. So this is why we are taking this amount as a negative value. Okay, so that means now we should add here minus V2. Okay? Then we will move from J to D. Here we are moving with the current, so that will be minus, okay, R3 I3. Okay, sorry. Okay, now we are reaching D, so because this is GD last thing. Okay, so we finish with that, and that will equals to 0. Okay, so what is R1? Actually, it is 8. So here we have R1 is 8. So 8I1 minus V2, we know it is just 10 volts. R3 just 4I3, and that will be 0. Okay. Okay, if everything is fine, you know now we have a relation between I1 and I3. Okay, very, very good. So from here we can say that we call it I1 equals to 10 plus 4I3, and this is divided by 8. Okay. Okay. So this is equation number 3. And in this equation, you can see now we are relating I1 with I3 here, okay? And here we are relating I2 with I1. We still need more informations, but also we have this one actually at the beginning here, okay? So I2 is just I1 and I3. So if you can substitute I2 by this one, then we have a relation between what? Between I1 and I3 again here. Okay? If we can do that, so if you can put, we can move here, and then we say, okay, substitute, okay, I2 from equation 1 in equation 2. Okay, so in this case, what we will get here, we know I2 is just I1 plus I3. So actually I2, this one here, I2 equals to I1 plus I3. So we'll take I2 from here, okay, and then we will make it I1 plus I3. And we leave the rest here, right? Okay? And so this will be equals to 4 minus 4 over 3. The rest is just mathematics, okay? I1. Okay? And from here we can move I1 to the other side. So that means it will be 4 minus 4 over 3 I1 minus I1 again. Yeah, so this will be I3. Okay, so far so good. So this will be, this is actually like minus 4 over 3 I1 minus 3 over 3 1, and don't forget plus 4 here. So just I'm making 4 a little bit farther here, okay? And I make I1 here instead of 1 I1, I make it 3 over 3, because this is, they have the same denominator, so then I can add them easily. Okay, minus sign, so that will be minus 7 over 3 I1 plus 4, okay? And this will be I3. So now I have another fourth relation. But I know from this equation, which one here? This one here, okay? From equation number 3, I know there is a relation between I1 and I3. Okay? So actually there is a relation between I1 and I3. Yeah. So that means if this is I1, from here actually I can get I3. I can prepare I3 from here. And I can make this one gives me directly actually 8I1, okay? 8I1 minus 10, okay? Divided by 4, and this will be I3. Okay, so I know I3 from here, 8I1 minus 10 over 4. Okay, I can bring this one and put it here. Oh, that's nice. That is very nice. And why is nice? Because at the end of the day, I will end only with one unknown. Okay, so now I have 8I1, okay, minus 10, okay, divided by 4 equals, let's go slowly, minus 7 over 3 I1 plus 4. You see now it will be easy to be, it's easy to be solved here because everything now in one unknown, which is I1. Very easy. How can we solve this? First, we can make it a little bit simpler. So this will be 8 divided by 4. It will be just 2. So 2I1 minus 5 over 2 equals to minus 7 over 3I1 plus 4. Okay. Now we can take numbers together. So here we can say that this is 2I1, okay, equal plus 7 over 3 I1 equals to 4 plus 5 over 2. From here, it is very easy. You can calculate I1 directly, okay? Because this one can be this 7 over 3 I1 equals to this one here, okay, which is 4 5 over 2. Okay, and from here you can get I1 directly. Okay, so 3 by 2 6 plus 7, that means 13 over 3. Okay, and from there you can get also 8 plus 5, that means 13 over 2. You can make yourself and get the result of I1. That's fine. Okay, if you get I1 from here, okay, then you can get I2 easily. Why? Because we know that there is a relation between I1 and I2 from here. If you get I1, you can get I2. If you know I1 and I2, then you can get I3 from here, because I3 equals to I2 minus I1. Okay, so now by doing this kind of substitution, okay, having three equations by 3 unknowns, you can solve by substitution different unknowns with different numbers, and then you can get your result. Yeah. Okay. So this is the last question for today, and thank you for your watching. Please like and subscribe. Assalamu alaikum.